Yes, we can. I can.
Okay,
great.
go ahead, Tammy. Thanks very much for your time.
Well, I would just like to thank everyone for taking the time to call in today, and mainly for us to just have a, an idea session about how we're going to do this project and do it well. And so what I wanted to do is that I told you gentlemen the last time that we talked is I wanted to approach the literature search like wide in scope to generate, a large reason that we can justify developing a research plan that might be a lot on the order of maybe I don't know, close to $1 million or whatever it's going to take for us to do a good job. And this is a lot different than what I had originally envisioned when I submitted my proposal, but I want to do something that, at least as far as the plan development, that we think that what needs to be done. So I went back and I just looked at some statistics. Basically, these were taken from the Energy Information Administration, so it's EIA.gov. In June 2016, U.S. electric utilities had over 150 million customer accounts, and these include 18.3 million commercial and 827,000 industrial customer accounts. And so what I was thinking, well, if we assume that each customer has one service, and the number of services in this country will exceed 150 million, and the number of distribution feeders and branch circuits are likely to exceed 1 billion. And if we think about the National Electric Code, which applies to about all new electrical installations in this country, where it's adopted and enforced, and it's been adopted and enforced statewide in 47 states, and it was first printed in 1897. So it basically applies to almost all installations in this country. And so, therefore, if we think about it, most of the 150 million electric utility customer accounts were probably installed per NEC requirements. So I think it's really important that someone address this research project, and I'm not sure where the funding will come from, but as you can see, there are a lot of feeders and branch circuits in this country. And if we can just go on to the next slide, since I'm in charge here, I guess I don't have to prompt you. In 2015, electric utility customers purchased 3.7 trillion kilowatt hours of electricity. Residential and commercial customers each consumed about 1.4 trillion, and industrial customers consumed about 1 trillion kilowatt hours. And the amount of electricity flowing in the feeders and the branch circuits, when you think about it, is just astronomical. And if we think about the feeders and branch circuits as being pipelines for electricity, and if the feeder and branch circuit sizing lead to energy losses of even 0.1%, the electricity consumed, we're looking at 3.7 million kilowatt hours of electricity wasted. And if they accounted for, if the feeder and branch circuit sizing accounted for 1% of electricity losses, we are looking at 37 million kilowatt hours of electricity wasted. And if we just took a rough estimate and said at 8 cents per kilowatt hour, that would accumulate to 3.7 million. So I think if we just look at the numbers in terms of electricity users in this country and the amount of branch circuits and feeders we even have installed in this country, that alone warrants a large research project like this. The other issue, which I included for you, Bob Yanello, because I know this is one of your big interests, is that there's a question, is improperly sized equipment introducing additional safety hazards, specifically, with higher available fault currents, additional arc flash hazards. The thing that I was thinking is I was also thinking if we have a higher available fault current that would also maybe imply oversized overcurrent protection devices and settings, reducing the sensitivity and response times. But on the other hand, for those of you like Bob who know a little bit about me, one of my specialties is really the arc flash hazard, is that undersizing equipment is also associated with overheating, equipment damage, and you know, if you're going to have damage, you're going to have maintenance and things like that, which would be interrupt business activity. But anything that's going to be undersized, you know, I'm very concerned about the potential safety issues that are going to be involved. So I'm extremely interested in this project with the idea that we're oversizing equipment, but at the same time, I want to make sure, if I'm involved beyond the phase 1, that we don't recommend undersizing equipment, because I'm concerned about anything overheating, because I know overheating leads to equipment damage, additional troubleshooting, maintenance, and electrical work or interaction with electrical equipment. And anytime a worker interacts with a piece of electrical equipment, there is a potential for an injury to occur.
Yeah,
Actually,
to add to that, Tammy, that's why we picked in the IEEE papers, we've written 3 or 4 of them already. That's why we use the word right-sized, because we know that we're looking at a trade-off. You know, we could even cut another separate project about, you know, to what degree it is a reasonable size. But anyway, that's what we agonized over that word. So I'm glad you brought that up, because we're not ignorant of that. That fact was identified in those IEEE papers, and we knew that would need some research and to maybe possibly rationalize over occupancy classes. Okay, thanks for letting me talk.
well, thank you for the clarification, and I would never think that you're ignorant, Mike, so no need to even say that. Okay, so the next slide is, now let's start talking. Less monologue, more dialogue. What I'd like to know is, I'm going to list here a few benefits that I thought of, but I'd like to know what your specific interest is in the project. Okay, if we find out, if we conduct a phase 2, very large-scale research project, and we find that electrical feeders and branch circuit sizing is leading to oversized equipment, and we make changes, some of the potential benefits might be reduced installation costs for new electrical installations, fewer energy losses associated with oversized equipment. And this was just my particular idea, that we might have a more optimal system protection and coordination. And then, of course, potential to reduce arc flash hazard. What I'd like to know is, what is your interest in the project, and how can you benefit?
Tammy, this is Bob. I guess the question, because Mike and I had this conversation a couple of years ago, how do you see that reducing the size of the equipment improves the efficiency? To me, we're talking I square R, and if I push the same current through less resistance, my losses increase, not go down. So help me with that one.
Okay. Well, basically what I was thinking is, basically we're going to be leading to right sizes, like distribution transformers, things like that. You know, if the transformers are oversized, we're looking at higher potential fault currents than we need. We reduce equipment size, we're going to reduce the potential fault current a little bit. And then as far as losses, if we actually, I'll have to go with this. If we replace transformers, especially according to the new 2016 requirements, we're going to be purchasing more efficient transformers.
If I could add to that, I want to add a bullet point here, is that I wanted to bring more renovation projects to the tipping point. This goes way back to one of the earlier articles you saw in EC&M magazine, and we felt that very often we do a new addition on a building, or there's a renovation. The first thing the architect says, I don't want a new substation, or can you pick some power off of an 800 amp distribution panel for my new research project? And of course the engineer does what he's supposed to do. I'd like him to be able to come back and say, well, I'm allowed to do these certain things now, and if you have a project, I'd like to rip out this 1968 power distribution panel and resize it, and maybe you can reclaim some of the electrical room or the substation room, and especially since we have some of the drivers being LED lighting. So I just, as a bullet point here, projects that are on the borderline of for whether or not an entirely, where legacy systems can be torn out and be economically justified. I get some language like that. That's all.
Okay.
Yeah, thinking about it, and I'll have to go back and think about it more, but I think that the losses would be reduced mainly by using higher efficiency equipment.
Okay, so putting in a transformer that's more efficient, so it'll be okay. Because like I say, that's one piece of it. The rest of the system are your losses as well. I mean, that's where a lot of the losses come from too. So I just wanted to understand the perspective from which that bullet was there.
No, I think that the answer is that we don't have a good answer yet, and that as I work on my literature review, I'm going to have to look at that and see if I can address that in a quantitative way, because this isn't about hand waving and that sort of thing. I'm going to have to see if I can come up with something very quantifiable.
I don't mind if a transformer is 2 or 3 or 4 times oversized. I will start to ask questions when that transformer is 8 to 16 times oversized.
Some point, shouldn't we wrap in the idea of sustainability? And if I'm oversizing things, these are not infinite resources. Copper, aluminum, all that stuff is not the energy it takes to produce larger equipment. It has a huge trickle-down effect if you don't oversize.
That is a very good point. I don't work in a very green, enlightened world like you folks who deal with energy conservation do, but I think sustainability is something that also needs to be mentioned.
Yeah, I think you're wanting to do what I think they refer to as a life cycle assessment, which would be from cradle to grave of a product's energy consumption and utilization and all.
Yep.
Okay.
I struggle. I've made proposals to the sustainability group, and there's lots of sustainability groups in the education industry, and their eyes glaze over. The proposals are rejected. It's behind the electrical closet. So why should they care?
Yeah, sure.
Okay. Well, let's go on to the next slide since time is marching on. Okay. As you gentlemen know, this project covers NEC Articles 210 through 230 on branch circuits, feeders, and services, which provides the calculations required for branch circuit, feeder, and service loads for all building types. There's also references to other NEC articles for many load types, including HVAC, refrigeration, motor, and elevator, heat pumps, and electrical vehicle charging stations. Of special interest, a focus of this research project is office buildings, and branch circuit loads are addressed in 220.12 and 220.14 for lighting and receptacles. Feeder calculations in 220.44 for receptacle demand factor. Okay, this is the history of the lighting load in the NEC. It goes back to 1935 when general purpose outlets, which were primarily used for lighting at that time, were 2 watts per square foot. And then NEC specialist Derek Vigstall informed me that the current table, 220.12, started to take shape in 1951. In the next slide, I'm going to show you the lighting requirements since 1968. That's the last NEC that's publicly available on the web. And I'm going to show you through the 27 NEC, and actually I think I have the ASHRAE requirements next to it. So let's go and look at that slide. Okay, in 1968 we're looking at these numbers, and so what I've done is here I'm showing the changes that have occurred, and then finally I'm showing the 2017 values. So since 1968, the requirement for banks went up to 5 watts per square foot. Then it was reduced to 3.5 in 1981. And office buildings went from 5 watts per square foot in 1968, and that was reduced in 1981. And those are the changes that have occurred in the last 50 years. I think that since the NEC applies to about, what did we say, 150 million electric utility customers, that warrants a little bit of second look at what's going on. I think that it's time for the NEC to at least consider that changes need to be made here. And if we compare that with ASHRAE 90.1 2004 and 90.1 2013, we'll see that these numbers are much lower, except interestingly warehouses, which is 3 to 2.5 times the requirement of the NEC 2017. The reason that I'm interested in ASHRAE 90.1 2004 is that I did some research on the DOE reference models for commercial buildings, and for new construction it uses the 2004 edition of 90.1, and I haven't gotten a response from the DOE yet, but I'm trying to figure out what substantiates their use of this table for current for new construction. And that's not specifically energy efficient construction, that's just their reference model for current construction. So it's my guess that 2004, that these numbers are probably a lot more realistic than what the NEC has. Also in the NEC 2017, which I need to bring up, if we can go back and look at the last slide, is that in the 2017 edition, finally, there's an exception that says if the building complies with a locally adopted energy code, and I think that's for offices and banks, I have to go back and relook, but it's at least for offices, then they can use the requirements in the energy code. But if it's not an office or bank, that you have to have monitoring on your lighting systems, and in addition to that, the demand factors in 220.42 cannot be applied.
Tam, I can enlighten, when you get to this part, we can write it up a little more, in a little more specifics. It was me and my work groups, and I'll call my partners in this on the NEC that made these. It actually started in 2014 with an exception number 3, which was a general one that applied to all of 2014, which said that if you have this, and this, you have an energy conservation program, or at least a system, you may calibrate your design load to what the limits of the energy code are. So that's, and you won't see that in the 2017 because that will have, they don't identify that specifically now. What you'll notice in the 2017 is we managed to sock through the office buildings. You can take it down to 2. I think you're probably going to do that on the next slide, but that's more restrictive. So that does reflect it, and we do have a video recording. I have to give credit to a colleague at the independent electrical contractors, Larry Ayers, who was able to was on that committee and was able to take our proposals, recycle them, and to push this through. I will also say that there's a pattern here on this, which you're showing up here. The organizations that can afford to advocate for themselves are the ones that have been able to get some reduction in there. 220 is noteworthy for all the exceptions it has, because it reflects the ability of certain interest groups to get their electrical design load closer to what do they actually see. Obviously with schools and universities, apart from what Paul and I and others have been able to do, we really struggle to get schools and down to the level that we actually see empirically. So I don't want to take any more of your time. I just thought I'd let you know that there's quite a bit of action in 2014 and 2017. And there is conceptual understanding by the members of that committee that something needs to be done. Unfortunately, people are getting paid to vote a certain way. Thanks. That's all I have to say.
And as I've told some of you, one of the reasons that I became interested in this project is I noticed when I was reviewing electrical drawings and panel schedules that the lighting loads were much lower than what I knew was in the NEC, and that's because that the engineers in the Atlanta area designing for this area were complying with the local energy code. And from what I understand, that I was trying to document how and where it's being enforced. You know, where is design conforming to local energy codes? Because if you look at ASHRAE adoption, either ASHRAE or a local energy code has been adopted in almost every state. I think all but like 5 or something. I've included it in my report. So what I'm having trouble with is why isn't it being enforced? And from what I've kind of heard from the folks at IAS is that it really just depends. There's no consistency, that even though ASHRAE is adopted in a lot of states, it's not being enforced. And so I'm guessing that based on what I'm hearing from Mike is that in a lot of parts of the country, engineers are still designing according to the NEC lighting standards. Well, I found this whole thing very mind-boggling. So if we go back and we think about the NEC 2017, the requirement of standing alone without an exception is 3.5 watts per square foot. And then what I was doing is I was looking at the CBEX 2012 data. Now what I'm looking at here is that the CBEX, that's the Commercial Building Energy Consumption Study, and it involves over 6,000, I think it's like 6,720 commercial buildings. And I've included a lot of the information in my report, and I personally think it's fascinating, so I hope you gentlemen enjoy reading about it later. But what I found was, I took their data and I analyzed it in Excel, is that on an annual mean basis, the electric power intensity in watts per square foot in an office building is 1.8 watts per square foot. And I mean, that's just like an annual mean around the country. That is extremely low. It is so low, I sent Mike an email last week and asked him what he thought, because I thought, you know, I could have made some kind of stupid mistake and not calculated this right. You know, I can make a mistake. Unfortunately, I'm aware of that. Well, and so what I actually did for a basis of comparison, because I didn't have any other data at the time, and I looked at my own house load. So last month, if any of you are interested in my consumption, here I consumed 1.05 watts per square foot for the month of August. And I thought, wow. And if I compare that to loading, okay, I'm loading my transformer, at least last month, you know, and the mean was 11%. So the papers that I read by Mike, you know, they're ringing true to what's going on in my home. I'm using that transformer at about 11%, and that's the month of August. So, you know, I don't know what I'm using the rest of the year. But then what I found on the web is I was researching these DOE office models. If we look at this slide, what I did is I looked at new construction in Miami, and the reason I looked at Miami is because for the DOE reference model, the only thing that I could find was total energy consumption, which includes other sources by electric, besides electric. But I thought that there's not going to be a lot of natural gas and fuel for heating in Miami. And the reason I'm just showing these offices here is because I thought, well, offices, you know, they have fairly low requirements for like hot water heat, cooking, and things like that might be natural gas. So I'm guessing that what I'm looking at here, this energy. Well, I converted it and calculated an energy and power intensity. Then I'm guessing that all of this energy is basically electric. Is that if I look at a small office and the watts per square foot is yellow, I'm looking at about 1.5 watts per square foot. That's an annual mean. And according to the NEC, we're designing at 3 watts per square foot. And so I'm inviting any feedback because I find it mind-boggling that our annual mean loads are so low compared to what we just designed for one component of the total building load. I mean, that's just lighting.
That's just lighting, right? So the controls we've added, the VSDs that we've retrofitted since the 80s, all that, even when you add all that, and the persistent reduction in low density, smarter ways of using energy, to some degree behavioral changes, we're still stuck up there. So, yeah.
Well, basically, I think of all the large loads that Mike basically kind of suggested that we're not addressing, like HVAC, air conditioning, ventilation, refrigeration, and all these miscellaneous electric loads, which can actually constitute a pretty large percentage of the total building energy demands. And so I really hope that I am involved, and if not, I hope I read the report, because I hope that the phase 2 of this project does some serious looking at, annual mean loading on our buildings. What are we looking at annually? What are we looking at monthly? What are we looking at, seasonally, diurnally? How are these load patterns varying? Because I'm really wondering, how are we loading our transformers? Are we doing this? What are we looking at peak load? At peak load, are we looking at what? Are we looking at 50%? Are we looking? I find it hard to believe we're looking at 80%. I wonder if we're looking at 30%. And the other thing I'm wondering is, and I'm sure Bob Yanello can probably answer this, but as far as overheating transformers and electrical equipment, I'm wondering, well, if it experiences a greater electricity demand during the day or for a short time, and actually I'm sure that Bob Arno knows the answer to this too, is what kind of short-term heating is sustainable by electrical equipment? And I think that's really a larger question in this project. So we can go on from there. I've really gotten interested in the details.
Some perspective is that, remember, NFPA is a fire safety organization, and these numbers were largely informed by how do we avoid a fire, and bringing electrical energy considerations into it was not primary. There's still a safety culture at the fire safety culture, and so that's some of the cultural basis for this. Go ahead.
Well, I understand that there certainly needs to be a fire safety culture, but the NEC primarily tried to deal with electrical installation, and then in more recent years they've had to address safety issues, although that's kind of mainly dealt with by 70E. I mean, in the last 10 years, the NEC has had to kind of incorporate a lot more safety issues as far as electrical hazards that they initially wanted to. And now I'm wondering if we're at the point in the United States that they're going to have to also kind of enlarge and start looking at energy conservation and being energy mindful. So anyway, if we can go on to the receptacle load. In 1935, as I mentioned, the assumption was made that permanent appliance receptacles would require at least 1.5 amps. In 1937, the NEC said that appliance outlets were going to be based on the ampere rating of the load. And the reason that you see 220.12a in parentheses is that's at least the 2014 edition. And that heavy-duty lamp holders at 5 amps, that's still 220.14d. And that all other outlets at 1.5 amps, which is corresponds to 180 VA. I think the NEC is in some ways like our state laws. I don't know about the states where you live in, but I know Georgia has some pretty peculiar laws that are still on the books. And they're like been sitting here for like more than 100 years, and no one has just bothered to remove them. And so the NEC is a living document, and I think sometimes it's easy to add, but at the same time it also needs to do house cleaning and make changes where necessary. So if we look at the 2014 NEC, and the reason I say 2014 is because I have a 2014 NEC sitting right here, and I don't have a 2017, but I'm sure the 2017 is most likely the same. That receptacle outlets shall be calculated at not less than 180 VA for single or multiple receptacles on one yoke. And that basically if you have 4 or more receptacles on a single piece of equipment, the load should be calculated at, that I put like 90 amps. That is totally wrong. I'm sorry. I meant to say 90 VA per receptacle. And then Table 22044 sets demand factors for non-dwelling receptacle loads at 100% for the first 10 kVA and 50% over 10 kVA. And that's another reason I was really interested in this project when I saw the RFP, because I've had my own experiences with receptacle loads. Now just some discussion points. I know other parts of the RFP talked about adding spare capacity to panel load. That certainly pads the load, but as years go down the line, are you finding that you're using it? Is it still needed? And the other thing is just any comments on transformer sizing. And I was also curious about what you gentlemen thought about any other NEC load calculations that you think might need specific attention.
Tammy, this is Paul. I guess the feedback I'd give you on panel boards is we tend to put a lot of spare space in the ones we have and have reasonable capacity. I do see that consumed, but I'm not sure I see that consumed so much from a load perspective as a circuiting perspective.
Right.
So as we see devices that are more and more energy efficient or use less energy, but we need more circuiting, that gets used. But I have not really seen us ever go back and deal with transformer sizing being an issue. It's always way more than adequate.
Okay.
There are some examples in hospitals. You know, when we went down this road, we understand that we're always getting the high voltage guys are saying it looks like we're going to max out on forced air rating on a double-ended substation over the hospital. There are a significant number of installations that are running out of power at the service. It seems odd what's going on downstream, however. So that's at least at the utility interconnect where I did a fair amount of my career. There was always a problem. Certain hours, I'll say maybe it was 80 at most 0.76 hours per year, where there was a problem at the service, and we were in danger of going into the forced air rating. And then of course you've got a rating beyond that, which is somebody with a hose, depending on the kind of transformer you have. If you have an oil filled, so a lot of it, it's the type of transformers are very subtle devices, believe it or not. Go ahead.
No, I was just going to say, I'm sorry, I didn't mean to interrupt you. I'm going to skip my discussion of my original idea because we've discussed it before and there are not any new participants. So I've talked to Barb Arno, and to have a valid scientific study, we need 40 data samples, or really we need load data from 40 sites. The site data must cover 1 calendar year. That way we'll cover all seasons and all load conditions, and the sites must be geographically diverse. In addition, my personal belief is that the study must cover new installations, and I'm just saying constructed within the past 2 years, or maybe 3, because this project addresses the NEC, which applies to new installations. Do any of you have other different feelings about the age of construction?
Well, I have a Go ahead. Go ahead.
I'm sorry, this is Bob Arnold. So the only concern I have about the age of the construction is to make sure that the facility itself is loaded up fully, and it's not a phased-in type of process for a particular location. I run into this quite a bit in terms of on the government side, where they will build a facility, and it takes them a year or 18 months to fully populate the facility and get the full loads. That's the only thing I would caution about.
No, what you're saying makes so much sense. And what do you suggest? Do you suggest we keep this, but we're just careful with the sites we choose, or that we should not be so time limited?
Yeah, I think we should be flexible. I think you ought to keep this because you had a very good valid point that it is for the most recent NEC code. Very good valid point. But I think we should be selective in the facilities that we identify and collect the information on, just to ensure that it is a fully populated facility. And if it's not, we should go on to maybe consider a little bit older facility that is a facility that is fully populated.
Well, how about if we open it up to 5 years?
Sure.
Okay. All right.
2 to 5 years.
And
2 to 5
next
years.
slide.
Does the new installations then, are we still limiting that to office space, or can that be, when you say new installations, are we talking more general than that?
Okay, well, we haven't gotten there yet, so let's try to work on that in a couple of slides. But I'm open. What I want to develop is the best plan possible, and that's why I'm so glad that you gentlemen took the time today, because that's what I'm trying to work out instead of just come up with my own plan, which probably would not be the best one. I think the more ideas, the more people involved, the better the plan's going to be personally. Okay. So this is the IAC climate zone map. I basically just included it in the slide for your visual relief, just to show you that we have to represent all geographic areas. And I've looked at this, and here they are identified, so we can handle that. There are actually 13 climate zones, and actually the DOE actually even discovered 3 more. That brings us to a total of 16, which the 3 more are basically right here. For 5, we have A and B, and for 6, we have A and B. And then Fairbanks, Alaska is actually, no, I'm sorry. And then what they did is they subdivided 3B, so we have 2 subclimates there. And then my point, yeah, it's very cold. Okay, my point here is that we definitely, I think as much as possible, need to be geographically distributed. But I don't think we have to say, okay, if we have 16 climate zones, we need 3 sites in each climate zone. And the reason that I say that is because the DOE also pointed out that 78% of the population was located in, I think, 5 climate zones, and that the buildings naturally tend to be located where the population centers are. So what I think is that we definitely need to represent these climate zones. I think we need to have 1 site in each climate zone. But I think we also need to consider population. Like, for example, I think it would be good if we could find 1 site in Zone 8, but I don't think we need 3 sites in Zone 8. So, I think this is really kind of a small issue.
Well, wherever there's a lot of construction activity, it strikes me that it could be effective in that area. There's certain parts of the country that are growing more than others.
Right. Okay. Now, this is really why I'm glad we're having the meeting is, well, first of all, what building types are suitable? Office, hospitals, education, dormitories, all commercial, all non-residential. One thing I was talking to some of you folks after the last meeting, and I realized that university campuses are really, they're communities. And when I was looking at the CBEX building types, I think there are like about 13 building types. Basically, a college campus houses all 13 types of buildings. And depending on what we decide, that, perhaps we should open it up to all buildings, perhaps we shouldn't. But I'm open to any feedback. And then, of course, I was thinking, should we open it up to even industrial? I definitely think we need to leave it non-residential. But beyond that, I'm interested in your feedback.
I'm very fond of saying that under my watch, when we tripled the size of the system, we had a nuclear power plant, an airport, and a football stadium you might have heard about. That was a joke. Oh well. Didn't go over so well. Not to mention an 1,000-bed hospital. So yeah, we are cities within cities. Industrial could be a different animal. That could be a different project, and I think you could probably get a lot of manufacturer funding on that one. That's probably Bob Yanell's area of expertise.
Right. I mean, of course, industrial might make it too complicated, but at the same time, if we're looking for a study that's largely self-funded, it also might be a good opportunity. I realize it's adding to the complexity. We don't need answers today. The main thing is that I'm glad we're talking, and when we have a meeting in a few weeks, we can talk again. I'm certainly not going to lay any plan in stone before then. I'm just going to take today's meeting and keep thinking, and while I'm thinking, I'm going to keep working on the literature review, and the more I read, the more I become, more, I would just say, open to what's out there. Another thing is we need to consider is when we add the building types, when we open that up, what about building sizes? How are we going to establish that criteria? So that's another consideration.
Could you put laboratories, since you've gone down the road of industrial, we have seismic laboratories that are big power consumers. So hospitals obvious, but every large research university, there's about 100 of them. They're all out there hustling for research dollars in their laboratories, and those are fairly it's very spotty, but there's a certain load profile for for laboratories.
Right. It's my understanding that a laboratory is a commercial building.
Okay.
So I think,
I would argue that that might be a building code occupancy safe egress type of classification. But you get my point. I'll just leave it there.
Okay.
Yeah,
well,
I kind of agree with Mike on that. With the our research laboratories are really our electrically most intense buildings, and that doesn't necessarily fit commercial to me from a usage standpoint, certainly from an occupancy classification.
One thing that people don't understand, I'll say this, is that the schools, when you see something in ASHRAE that says schools, that's usually K-12, and there's a certain type of load profile per the year. But it turns out that in higher education, that most of it is classified by the building codes as commercial, which is startling to a lot of people. It's not instructional. And if you're like a university I know, there are two administrators for every student, and that seems to square with what we see. So much of higher education is support for laboratory research, student outreach, and such and so forth. So I'll just make that point that over half of higher education is commercial.
This is Bob Yanello. I would think that with any of these sites that we assess, there have to be some kind of a factor on it, like an occupancy factor or a utilization factor or a demand factor, something that kind of identifies, for the original 100% capacity, occupancy of the building, whatever it is, what was that factor at the time that this assessment was being made to determine, because like I said, we're just going to be looking at points in time, even though we're looking over a year's period, look at economic conditions and things like that. It seems like a factor like that would need to be applied to any of these types of facilities.
Okay. I understand what you're saying, and that was basically part of my idea for new construction. And as I was thinking from what I'd read about building trends, that if we think of a new building before it had kind of gone through some kind of attrition for whatever reason, that it would be basically at 100% its usage. But then, of course, Bob Arno pointed out that it's going to take time for a lot of places to scale up to full operation. So I think that unless I don't understand that part of what we could do, that's just going to be is our selection. That in our selection process, we're going to have to make sure that the building is fully used for its function. Is there anything else?
Yeah, we're probably not going to find any place that's fully used, at least at the time we're assessing. That's why I think some type of a factor applied to our numbers, is probably appropriate.
Okay, so we're going to have to, especially when we review the facilities, we're going to have to basically rate it.
That would be my opinion. I just think of our own facilities and, how depending on what our volumes are and whatnot and the number of employees we got from one point to the other, it can range very broadly. It happened with the dot-com bubble in the turn of the century here. A lot of people had to lay off, and we had the downturn in 2008. So those types of cycles can affect the numbers, one way or another.
Well, one thing I think really important that you brought up is as far as our data queries, we're going to have to know the number of employees on site, because that's kind of like a benchmark. Because if you look at CBEX and DOE and the DOE model and other things, that's kind of our assessment, is we can see where the building is. That's like one of the ways that we will categorize and describe it. That's part of the data.
Well, I think more than the number of employees, it's a percentage. So, what was the total occupancy capability of the building, and how does that compare then to the number of employees? Because just the number probably won't tell us anything unto itself.
Oh, I understand. I think both are useful. Thank you. Okay, we can skip the geographic thing. We've kind of covered that. The other thing was I started talking to someone last time, is that how to monitor lighting, receptacle, and other loads. Is I'm really concerned about this, because even in new construction, panels are rarely dedicated. And how are we going to actually literally monitor the lighting load itself, the receptacle load itself, and other loads? Part of my initial idea was kind of like a small sample survey. It involved 5 buildings, and I was actually going to review the lighting layout and calculate the fixture power requirements and things like that. But on a large scale, practical, scientifically valid study, how are we going to do this? That really concerns me. As far as receptacle load, well, if we wanted to, we could get little plug-in monitoring devices. And I saw a very interesting study at Lawrence Berkeley Lab, and I've contacted the person to try to find more about it. So that is doable. If it's feasible, that I don't know, but it is doable. But as far as just lighting, how can we evaluate that? And should we try to evaluate like the HVAC load? Well, I shouldn't lump it. I mean, should we try to monitor the air conditioning load, the ventilation load, refrigeration loads? What do you think about monitoring individual loads? And if we don't monitor them individually, how are we going to address the specific NEC requirements?
Well, this is Mike. The first cut would be 277 volt lighting. Sometimes you can pick that up at a substation feeder breaker, for example. On the other loads, you could also, there's a great deal of building automation control information available from the building, the environmental air systems. So it's possible you can get something there, but it's
no, I was talking, I communicated with Brian Myers after our last meeting, and he pointed out that even in new construction, he rarely sees like a dedicated lighting load. And I can about confirm that I rarely see a load that is 100% lighting.
In large office buildings where you have bulk 277 volt lighting, they're generally pure. Maybe farther out in the life cycle, some architect is pressing an electrical engineer to not put in something, so he'll do a 277 120. He'll do some kludgy things. But in general, I think for the larger buildings, the 277 volt But I mean, but there are exceptions. I hope that's a little bit helpful.
Is that something that it's just going to have to be part of our evaluation? Is that we're going to have to like evaluate, what they have on their panels? I mean, basically, I'm just looking for feedback here.
Tammy, I would agree with Mike. It is something you want to ask. 480-volt buildings, which have 277-volt lighting. I know on our campus, we typically separate receptacle and lighting loads into dedicated panels. So you just got to find buildings that give you that opportunity as part of the sorting process, I think, up front, so that you can differentiate.
Okay, and as far as receptacle load, I don't think I have ever seen a panel that's just all receptacle.
No, but I would think that...
I was going to say, I'm not a design engineer, but from the drawings I've looked at, and the panel schedules I've seen, I don't think I have ever seen one panel that is just receptacle.
But I would think a branch in the panel is going to be dedicated to receptacles. A branch is going to be dedicated to lighting, as opposed to the entire panel being dedicated to lighting or receptacles. Okay,
well, one branch circuit. So if we just think about a panel, and I'm just going to say, let's say there's 20 circuit breakers on there. I don't think it's very feasible to monitor 20 circuits for, if we're looking at, what's one circuit going to be? Like, let's just say, 1,000 watts or something. That's why I'm asking you. I mean, how can we make this feasible?
It's 108 watts. One thing, I think you'll find that certain occupancy classes like commercials likely would be within, there'll be very little, I'll say, corruption of the power chain. If you get in the building, like a laboratory building, where all kinds of programs are coming out and there's quite a bit of what we call churn, then you're going to see all kinds of stuff happening. You'll see cross-feeding of electrical load types. So I guess I'm going to put that out to others who have seen how renovations and how feeders and branch circuits evolve over time. I think laboratories are the ones where so many programs are coming in and out. We see a lot of cross-feeding, say, halfway through the life cycle. But early on, I think a new, spanking new million-square-foot office building for fresh and ready for administrator types, I don't think you're going to see a lot of corruption of the load classification there.
Well, are we going to say if a panel is basically 80% receptacle load, then we're just going to go with it, and that's how we're going to classify it? I mean, there's going to have to be some kind of discrimination there, I think, because basically from what I've looked at, I do look at new plans, I mean, new drawings.
I think when you let this out in the world, you're going to get a lot of electrical inspectors who have frontline experience, and I leave it open and open for their input because they see all kinds of crazy stuff happening out there.
Okay. Okay, well, basically it's 12 o'clock, and I know my time is up, and so I'd like to just know if anybody else has any additional feedback, and if not, all I can say is thank you so much for taking your time.
When would you like to do it again?
I think a few weeks when we have our regular meeting, that maybe we can proceed a little bit more. I'm planning to basically, summarize some of the main things that I've found out and I find very interesting, but then I'm hoping about half the meeting we can basically just discuss the research plan again.
Do you want to do it during the regular I think the E&H meetings are that agenda is just too crowded even now. There'll have to be a breakout meeting. So you pick a time, and we'll get it out there.
I think we just need to wait to the next Research Foundation meeting, which is I think we're going to have it about the third week in October.
Okay.
So I think that's
now that's Casey's meeting.
Good.
That's Casey's meeting, right? Okay.
That's Casey's meeting.
Good.
Tammy, this is Paul. One thing that might make this helpful at some point, doesn't necessarily have to be now, but and some of it we talked about today, I think if you could start to put on paper so that we could all comment on it, sort of those interview questions as you're looking for a facility to qualify, and then also what's your vision for what does a monitoring plan look like? To what level of monitoring are you looking? to do, because then I think for some of us, I know for me, I can start to think about facilities we have that might have existing metering or how we would fit into that profile and maybe give you a qualifying facility. Because some of the issues you raised, I think it's, if you're only going to go try to find 40 or 50 samples, then we got to find buildings that fit that criteria rather than take buildings and try to jam them in there and make assumptions or calculations because they're not very pure. I think you're shortening it up to newer buildings, as Mike said, will help because they don't change over. And I know in our case, a lot of our facilities are pretty well segmented from a load standpoint. Whether we have the metering to do that is a question, but that's why I'd need to know at the level you want to go to.
Okay. Well, before the next meeting, I'm going to plan to redevelop, you know, kind of what I'm thinking. And hopefully we'll just start with review processes, and I'll work on the literature review part-time, and then I'll just kind of work on this along the way. And instead of just being, well, I'm going to do the literature review and then I'm going to do our the data collection plan, I don't think that's a good idea. I'm just going to kind of do them both at the same time. And that way we can have several design reviews along the way.
Sounds good.
Okay, anybody else? Bob, we have our sponsors here. We want to be particularly sensitive and grateful to Eaton and Iowa and Notre Dame and others. Looks like we lost Kane. Kane, you still there? Yeah, he probably had to jump off. So I will download this meeting. I'll put this up on the IEEE E&H committee website for the moment. And probably I'll pass it on to Casey, of course, and he may want to put it there. I'll likely see Casey in Washington later this, no, I guess it's not October yet. I'll be talking to Jim Pauley and to Casey in Washington third week of August. You know, I'm working on a general plan for getting IEEE and NFPA working a little bit closer together. So this is a very good example of how it can be done. Anybody? Okay then.
We're good.
Thank you very much for your time, and I'll see you all on the worldwide inner tubes. Take care.
Thank you.
Have a good one.
Bye bye.
Bye.
Thank you, Mike. Bye-bye.
Bye.